experimental work. So you can see the slide number 3. So this is what today we want to focus on. So the method, you may ask why it is named as fourth order, because this numerical for Ranggi Kota, there is first order, second orders. So the most one is the fourth order. But you may ask, what about fifth order, sixth order, and so on? So at least by knowing and doing this fourth order, we assume that in the future you can do fifth order. So more importantly here is we want to solve the initial value problem for ODE, particularly because this one is designed for first order. Of course, we can extend this to the second order, third order, and so on. For postgraduates, research, well, order only. First order, fourth, or fourth. Of course, the order here is the fourth order means. But when you say first order, second order, third order differential, that format. So again, we have to repeat
Hello, sir. You are muted, sir.
Okay, sorry. This formula should no derivation, no what we call like Laplace transform, fusion or Wronskian. These are the very lengthy process. This calculation because we are doing manually using calculator. That's why this time the iteration. You see the x subscript I plus 1. Let's pay attention. This one xi is previous input. It's the next input, and then you find your y. Next is connected with the whole. So the y x subscript plus y is the next output. It's just one formula, but the k1, k2, k3, k4 you calculate 4 times. You have to spend some time, but if you are hurry-burry, then you answer this calculator and then redo again, because all these are interconnected. K1 like so. Our explanation is very simple, nothing much here. Y x subscript I plus h over 6 in the bracket k1 plus 2 k2 plus 2 k3 plus k4. The h is here. The h is called this. This is different from Laplace transform, different from Wronskian constant. Yeah, sorry. So internet problem. Can you hear me, class? Ui, can you hear me now? Ui, can you hear me now? Okay.
Can, sir, can.
Thank you. Okay, go back to slide number 6. So this formula is one single formula. This you calculate yxi plus 1, but we explain here step by step because this one is for the beginners. When you begin to solve the problem, we have to explain everything, A, B, C, like that. But later on, you can use shortcut. You can get the yxi plus 1. What we want is the final output.
Sorry, sir. We cannot see the slide.
I will show you. Then open, click the one under ME. Fourth order Rangikuta. Can you see? Slide is there. I already opened the slide. Can you see the slide?
Sir.
Huh?
No, sir. I cannot see the slide.
Okay. Okay, now
Yes, it's visible now.
sorry, internet problem, yeah? So once the internet is out, the slide goes. All right. So the major problem here is, yeah, for the beginners, you have to be patient because you have to calculate K1, 2K2, 2K3, K4. So this one I explain here. You may wonder whether you want to memorize this formula or not. Yeah, we understand very hard to memorize. Formula will be given. If it's not given, you can refer to any reference book. But stick to one formula only because there are many styles, not different styles of writing. STYLE style. So you stick to one, then when we check output is wrong, then no point. So that is very important. But we know how to get the correct output. So the K1 is called fxiyi. This fxiyi is the dy dx, the first order. You must write dy dx from the beginning of the problem. Dy dx is xiyi. But this xiyi is just to calculate the dy dx. Just put the x0, y0, you calculate, you found K1. But when you calculate K2, this is the problem. The x become xi plus half h. H will be given. So you know already the x input. The y input is slightly different. Yi plus half K1h. The K1 you already calculated here. You later how to calculate the yi plus half K1h. K2, after you found K2, you move on to K3. K3 is f of xi plus half h. This is the same. But the yi plus half K2h. This one is K2 class. So this K2 you must calculate from here. This one goes inside here. H is the same. And K4 is totally different. F of xi plus h only. And the y is plus K3. You must get this K3 put inside here. This is for the first iteration. But inside this first iteration, you are in the process of finding yxi plus 1. This K1 all is inside this. There are two things happening here. One is the outside iteration. The other one is inside iteration. The loop. This is actually a loop. You are substituting K1 inside here, and K2 here, and K3 here. Calculate K4. Take all these value, put inside here, and then calculate the Y final output for one iteration only class. substitute xi with I0. We call it x naught. This xi plus 1 become x1, x subscript 1. What does that means? That means we put x naught is initial input. Then what is the output for the next input? I plus 1. So you start with x naught, y naught. Next one is x1, y1. Like that. It's like that. And then the following one, x2, y2, x3, y3. Like that it goes. So it is like non-stop iteration. But we have to stop somewhere. That is the problem. How to stop? Where to stop? This one falls under some criteria. They call it stopping criteria. But we cannot keep on doing x naught, what is y naught? X1, what is y1? X2, what is y2? X3, y3. This iteration is very good because you can do the final analysis, how the output behave. That one we will not do it here because that is for further analysis. What we are going to do here is how to calculate the first output for the given input. And then the differential equation, the first order differential equation. So in order to explain the whole process, you see the example here. So the example here is dy dx equals to xy divided by 1 plus x squared. I want to show you something, the relationship between this chapter 4 with the chapter 1. Take a piece of paper with the pencil. Yeah? dy dx equals to xy divided by 1 plus x squared. We want to solve this fourth order using fourth order Rangi-Kutta method. Estimate y, this word estimate, approximate. So you are finding the approximated value y at x 1.1. What is the meaning, class? Meaning is you are given value y1 equals to 1. This one meaning when x is 1, the h is 0.1. When x is 1, your y is 1. This is already known. When x is 1.1, what is your y? We do not know yet. So if I start with x naught, y naught, that is the meaning. X naught is 1, y naught, y subscript 0, we call it y naught, is 1. At x1 is the next x 1.1. What is my y1, y subscript 1? That is the question. That is the story of this problem. But this is one iteration only. If I ask you, proceed to x 1.2, then you do the next iteration with the same h. That means 1.1 plus 0.1, answer is 1.2. So at x 1.2, that is at x2. What is my y2? Just now you found the first iteration. For the x 1.1, we found the y. And at x 1.2, you can find the y. At x 1.3, we can find the y. Okay, now pay attention, yeah? This is what we are going to do using the fourth order Rangi-Kutta method. Question must be clearly well understood. Given this one, this is your fxy class. The left hand side must be only dy dx, 1 dy dx, no other term here. You see here, this one all empty. That means here is 1. dy dx equals to xy over 1 plus x squared. This is your fxy. This is your fxy. So fourth order Rangi-Kutta method to estimate y at x 1.1. Now, this problem, dy dx, I'm going to solve this using separable method. Chapter 1, yeah? Write down, yeah? Separable method. You separate dy over y equals to x over 1 plus x squared dx. Write down, yeah? Separable method. The name of the method is separable method, chapter 1. So dy over y equals to x over 1 plus x squared dx. So you integrate respect to y, left hand side, integrate x, right hand side. The reason why we are going to do this is we want to find the accurate solution, analytical solution using the separable method. So when you integrate respect to y, dy over y, you will get ln y. Write down here, ln y equals to x over 1 over x squared dx. If you integrate, you will get half ln 1 plus x squared plus c. The problem is the c. In order to find the c, we use this one. When x is 1, y is 1. So you substitute x1 ln 1 equals to half ln 1 plus 1 squared 2. So ln 1 equals to half ln 2 plus c. So c equals to ln 1 minus half ln 2. But ln 1 is 0. So your c is minus half ln 2. Now you substitute back the c. You get ln y equals to half ln 1 plus x squared minus half ln 2. And take out the half outside. Ln y equals to half ln 1 plus x squared divided by 2. And then bring the half over. You cancel off the ln. So your y will be equals to 1 plus x squared over 2 power half. That means the root of 1 plus x squared over 2. Or you can write 2y squared 1 plus x squared. Or you can write y squared equals to 1 plus x squared over 2. This is exact solution from separable method. We keep this aside first. We can check this later on with the Runge-Kutta method. We test the Runge-Kutta method whether at x 1.1 the answer is the same with the separable method. Any question, class, so far? Hello? Any question?
Sir,
Yeah.
do
So
we have to integrate?
the answer is either y equals to integrate. Yeah. Integrate 1 plus x squared. X squared. Sorry, I'm writing now. X squared divide by 2. But the whole thing Are you there, Najmuddin? Najmuddin?
Yes, sir.
Can you see the... Hello?
Hello, sir.
Can you see the slide?
No.
Okay. Shall we continue? Sorry about that. Internet problem. Sunil, Sunil Singh, yeah. Sunil internet problem. Sorry. Can you see the slide now?
Yes, sir. I can see the slide.
Okay. Internet problem, yeah? So just leave the call. Sunil Singh, are you there? Okay, shall we continue class? Hello? So the solution, analytical method, you can write as 2y, I'm writing 2y squared equals to Okay, class. Okay. Okay, we continue, yeah? Class, we continue. Sorry about it. So, yeah, can you hear me?
Yes, I can hear you.
Yeah, what is the problem? Just wonder that integration part in this chapter. So the answer is 2x squared equals to 1 plus x squared. Can you get?
Yeah, I think I can get it, sir. I got it.
Hello, Chia?
Yes, sir. Sir? Yes, sir. I think I already got it, sir.
So, yeah, so squared, y squared, yeah, y, yeah, y squared equals 1 by 2. So y is root of 1 plus x squared over 2. All right. So that is your exact solution. Yeah. Now, we want to solve this by using Okay, class. Chia? Okay, continue, yeah? Oh, calculate. Sorry, class. Sorry, very sorry. Now we are So K1 xy1 plus squared. You calculate K1 x naught 1, y naught 1. So 1 multiply 1, 1, divide by 1 plus 1 squared. This is 0.5. And this is your K1 value, yeah? Take down. So 0.5. So we found that 0.1 using the K1 F11 formula. Now K2. K2, these steps for the beginners only, yeah? We are showing you how to calculate K2 using this formula. Xi plus half H, yi K1H. So you cannot calculate K2 without calculating this first. Calculate Can you verify? Hello? Can you verify? 1.025. Can you get the answer? Hello? Can you get the answer, Chia? All right. So once you have 1.025y, x 1.05, you go to K2. So K2, you are calculating f 1.05, 1.025. So K2 equals to, using this formula, dy dx, x multiply y, 1.05 multiply 1.05 0.518. Can you verify? Proceed to xi plus half h, still the same. The x still the same, 0.05, but your y is different now. Your y of k2h. So your k2 is this value, which you got from previous slide. So you calculate now 1 plus 0.5, 0.51189 multiply 0.1. Can you get this answer? 1.02559. Please check. Please check. I'm waiting. Muhammad Amir. Okay, Muhammad Amir is different, yeah, from Muhammad Amirul, yeah. Yes. So now you have K3 ready. Move to K3. You already got. Now you move on to K4. K4 different. Xi plus h. So in 1. And then yi1 K3. K3 is this value. 0.51219 multiply h 0.1. Check whether this is correct or not. 1.05122. Verify and let me know now. Okay. Make sure you calculate, yeah? Chia, are you there, Chia? CH. Already have K1, K2, K3. Next one is all the values. You put it here. Now you calculate y at 1.1. At y at 1.1, this is yxi, the previous x1 plus 0.1. You have to use this formula, yeah? You must use this formula. So K1 0.5 plus 2 K2 0.51189 plus 2 K3 0.51219 plus 323. So you calculate, you check, can you get 1.05119? Please check. Please check, class. 1.05119. Okay, can you get class 1.05119? Hello, please verify. Hello? Chia? Muhammad Amirul, can you verify? Can you verify the answer 1.05119? What about others? Chia, are you there, Chia? Muhammad Amirul. Others, Chia? Yeah, your answer is correct. 1.05119. Can you answer why at 1.1? Why at 1.1 is 1.05 119. 5 decimal to check your answer square over 2. Substitute x 1.1. Calculate y equals to root of 1 plus 1 squared over 2. Using the separable method. So can you answer? What is the answer? Using separable method, just now we already, can you calculate y equals to 1 plus 1 plus 1.1 squared. What is the answer? Can you tell me, Shah, what is the answer? Shah, what is the answer? Hello? Shah, 1.051189. So if 5 digit, so you get 1.0511. Yeah, we compare with the Yeah, class. So now the idea here is, yeah. So I'm answering your question. For method, separable, the Rangekota method, you get the answer. Rangekota method is 1.05119 for 5 separable method 1.0. So in this case, we are solving Rangekota. We investigated is Rangekota method is good or bad for this particular problem. So we verify the method is bad. Since this problem already we solved using separable method, so we know to use Rangekota to solve this. But in the future, if any problem, you cannot use separable method. So at least this give you a good satisfaction for you to use Rangekota method. If you say Rangekota method is long, any problem. So the iteration, because you are doing manually by using calculator, but if you use software, computer programming, you can get the answer within a few seconds. on again, what is the equation? So the question here is, what can ask we can ask only doing. So in this case, we are only doing, but it's better for you to do further investigation using global method, linear, exact, non-exact, and Bernoulli. So far, you already studied Bernoulli. Bernoulli also first order, we can solve using Runge-Kutta method. But sometimes you cannot solve. So the message here is, at 1.1, answer is 1.05119. Now you see the table. Just now you say it's take long hours. What we want end of the day is in this table. This table is very important. Next time when you give the answer, you show all the calculation as a what we call sketch or scribble. You put your final answer this table. This is where it gives you very fast what we call display, what we call kind of letting others know with a very impressive manner how you display your output in the form of the table. So for Runge-Kutta method, the best way to display your final outputs respect to inputs is in the form of table. The table not include only input and output, X and Y, but include the K1, K2, K4. This is very good for the examiner to understand. Now we already know, given X1, Y1, you calculate 0.5, 0.51189, 0.51219, and K4 0.52323. Now using first the second row, X1, Y1, K1, K2, K3, K4, we calculated at X equals to 1.1, we found out the Y 1.05119, and we verify this value with the separable method, and we found out the answer is exactly same. If 5 decimal place, then we say the error is almost 0, but we don't go into 6 or 7 decimal places. So when you compare, then you have to compare with the equal number of decimal places, because just now you answer in a different decimal number. So decimal number is important for the sake of accuracy. Now class, you can quickly do X 1.1, Y 1.05119. What is the Y value at X 1.2? So at X equal to 1.2, we want to find what is Y. Can you calculate K1 now? All of you, yeah? Calculate K1. F 1.1, F at X 1.1, Y 1.05119. You calculate K1. 1.1 multiplied by 1.05119 divided by 1 plus 1.1 squared. So you should get K1, this one, fill up, yeah? 0.52322. Can you verify this class? Your K1. So now we are calculating at X. You are calculating K1. K1. 5 decimal places. At X 1.1, Y 1.05119. Can you get 0.52322? All of you. Can you verify this class? K1. This is K1, 0.52322. Yeah, Chia. Wang Chen. Wang Chen, are you there, Wang Chen? Wang Chen. Hello? Chia, can you verify that, K1? Shah, can you verify? Mohammed Amirul, can you verify? Amirul. Okay. Now, K2 f of 1.15 x 1.15, y is 1.077351. Therefore, your K2 1.15 multiplied by 1.07735 divided by 1 plus 1.15 square. So now you calculate your K2. So your K2 equals to what? K2 0.53346. So you calculate. Make sure you calculate 0.53346 and put it here. Your K2 here. You put it your K2 here. Can you verify, Muhammad Amirul? K2. K2. Are you there? Anyone? Okay, you can calculate. Take your time. I'm waiting. Others, what about Shah? Are you there, Shah? Wong Chen? Shah, are you there, Shah? K2. So I'm waiting for you. K2, can you verify? So using the formula, the same formula, K2, this formula, yeah. Xi plus half H, Yi plus half K1H. Use this formula. Okay. Very good. Yeah. Yes. Okay. Now you go for K3. So now you want to find K3. K3 f of 1.05 y 1.077863 f 1.05 y 1.077863. So your x is 1.05, y is 1.077863 divided by 1 plus 1.05 squared. So you calculate your K3 now. Okay, give me the answer, please. Anyone? K3. 5 decimal places only, yeah? Yeah, Patricia. 0. K3, 0.5, no. 0.53371. Yes. 0.53371. Please check, yeah? You got to do it now. Please check. You got to do it now simultaneously, yeah? Use your calculator now, calculate. Yeah, Patricia, you are correct. Now you go for K4. K4, K4. Calculate K4 class. K4. 5 decimal only, yeah? K4 equals to 1.2 multiplied by 1.0456. 1 divided by 1 plus 1.2 square. So what is your answer? K4. Yes, class, I'm waiting. Yeah, Wong Chen, you can try again. K4 class, K4. K4 equals to what? Yes, class, K4. It's very fast. Yeah, Patricia, 0.54323. Yes, correct. 0.54323, correct. So now you have K1, K2, K3, K4. So you calculate the output of Y at 1.2 equals to what? Output of Y 1.2, that is 1.05119, 0.1 over 6. In the bracket, 0.52322 plus 2 multiplied by 0.53346 plus 2 multiplied by 0.553371 plus 0.54323. Give me an answer, 5 decimal places only. Use your calculator. Yeah, Chia? Are you there, Chia? Wong Chen, Muhammad Amir, Muhammad Amirul, Wong Chen Shah, Wong Chen Shah, Shah Chia, are you there, Chia? We are calculating the Y output at X 1.2. This is the second iteration. Yeah. Yes, we are waiting for you. Answer, please. Y at 1.2. One point 10 454 or 454. Yeah. Yes. Yes, correct. Yes, correct. 1.10454. Yeah. Yeah. Good job. Right. Mohammed Amirul. Yeah. Okay. I think you missed it. The 4. Yes, I got the same. Wong Chen. At last. So the answer for Y at X 1.2 is 1.10454. So answer is 1.10454. This is the correct answer. So 1.10454. Okay, now you use the formula, the Y equals to 1 plus 1.2 squared divided by 2 and take the square root. What is the answer? Y? 5 decimal places. Using the analytical method. Can you calculate, Wong? At x equals to 1.2, you plug in the formula y squared equals to 1 plus x squared over 2. But y must be positive, yeah? So y is a root of 1 plus 1.2 squared divided by 2. So can you calculate the exact value? 5 decimal places. Using the separable variable answer. One 1.10454. Yes. Yeah. The answer is 1.10454. Yeah. When x 1.2, you are getting 1.10454. Okay. So that means the exact value same as Range Kota value. That means the Range Kota RK method is a good method. So that is the conclusion. It's a good method among the numerical method. So the comparison is to just to test how good is Range Kota. So compare with the Euler method and Yoon's method, because this problem can be solved using Euler and Yoon's. But the Range Kota method outperform Euler and Yoon's method. This must be tested for each problem. I'm not generalizing. I'm telling for this particular problem. Any question, class? Because the next example I'm not going to discuss. You can do on your own. You can test the answers. 1.2 we already got. 1.3, 1.4 you can do it at home. You can try. So this is a good exercise. At X 1.2 we already done. X at 1.2 already done. But X at 1.3 you can try. This is a good exercise. Not now. You can do it at home when you're free. So you try to complete this table. Yeah, you try to complete this table. Now this one, the third row, 1.2, and then 1.3, and then 1.4. You can stop. 1.4, you can stop. So you complete the table. This will give you a wonderful exercise and good experience. 1.2 you already found already. Answer is 1.10454. 1.3, 1.4. So almost you can complete this table. 1.2 done already. The answer here, you fill up 1.10454. The K1, K2, K3, K4, you can fill up this. Fill up this table. And then 1.2, you already got Y, but you have to find K1, K2, K3. And then 1.3, fill up K1, K2, K3. And then 1.4 is the last one. Of course, this part is for 1.5, but still you can fill up this. So looks the table is completed, like what they have done it in example 2. You see here? So like this, complete table. So when you give this gives you a good impression that you successfully completed solving the Range Kota. But the problem here is the computational time. So as you know, you are using calculator. So this cannot be very fast. It will take some time to calculate. So that's why you need more time. We cannot do it here. You can do it at home when you are free. Any question, class? Any question, class? So announcement regarding the test 1. Test 1, November 4. I don't have much information. November 4, 9 p.m. 9 p.m. And then chapter 1 and 2. Any question, class, regarding the test 1? I don't think so. No MCQ. Maybe not sure. I'm not sure about this. At the moment, I don't have much information on this. How long is the test? I only have 3 items. Date, November 4, 9 p.m. And the chapters are 1 and 2. So about the question you asked, how many questions? I don't have the answer. How long the duration? I'm not sure. MCQ or not MCQ? I'm not sure. We ask whether MCQ or not. So I'm not sure about this. Skanda, how many questions, sir? I'm not sure how many questions. We ask about how long the duration. Also, I'm not sure. When can ask how long is the test? I'm not sure. Sir, can you help? Sir, can you help us ask? We'll try. Class. So that's all for today. If you have any question, you ask me now. Otherwise, I would like to stop here. I'm sorry about today's lecture. Internet problem. So next week, I will deliver from another location. Yeah, we very strong. Today, I apologize for the inconvenient cause. Yeah, when can any questions? You can wait for the announcement from Dr. Mohana. Send him an email. Yeah. So I'm very sorry for today. Internet is very yes, Wednesday got class. Mohammed Shalihin, no question. Very good. Mohammed Shalihin, do we have class this Wednesday? Yes, as usual. As usual, we may do a revision again. Maybe we can do just to get prepared for the test one. Yeah. Chow Jit, where were you, Chow Jit? I didn't see you, Chow Jit. Chow Jit. Natasha, where are you? Natasha, I didn't see you. Huh? Okay, thank you very much. So all the best. Huh? Thank you very much. Yeah, sure. Yeah. Okay, we stop here. Huh? So I will stop here. Thank you very much.